Welcome to Brain Vision.
So in this question, we are given this graph of the kinetic energy, the rate of change for the kinetic energy versus time and versus distance for a wave. And we are given a couple of parameters. We are told what is the mass density of this. And from this can read two more things. One is read that the period is millisecond because this graph is one period. It looks like it's for our this is one period for the wave because this process is when it's going from maximum to equilibrium. For this is it goes to like a minimum because kinetic energy is it is still positive, but this is actually a minimum. And then it goes from minimum to and then it goes to another. So this whole thing is like 1 p. That's why it's 2 milliseconds. Similar here, as the wavelength equals 0.2 meter. And now for what is the amplitude of this wave? And in that we need to figure out how is Rs related to the original wave. So if you have equations that you can immediately use, I'm going to derive it here. So Rs, what is Rs? Rs is rate of change for kinetic wave. So let's first look at kinetic energy. Kinetic energy equals 1/2 of mv squared. So in this case, m we know the mass density mu. M is going to be mass density times mu l. L, whatever, it's just like some distance that we're considering. I mean, because if we're looking for the kinetic energy, we must be looking for the kinetic energy of a fixed length of string. So L is like that length we're looking for. And then what is V? V is dy over dt. It's a derivative of the distance. So we look for the dt. Dy over dt is ym times omega times cosine kx plus omega t. So this is, if we simplify it, a tiny 1/2 of mu l ym square omega square cosine square kx plus omega t. But now we're looking at the rate of change. If we are looking at the rate of change of this thing, so firstly, this number, it has maximum of, because at maximum square will just become 1, is 1/2 of mu l ym square omega square. And then if we're looking for the rate of change, t, this, then what is that this L becomes over t, and the L becomes v. So v is the speed. This is a max over t. So this is equal to the max rate. And max rate, we know it's 10 watt. So now that we get this, we know how to find y from all the other numbers we know. Ym equals 2 times 10 watt over so I mean actually 2 times max over mu v omega. And then we know that v is times lambda, and omega equals 2 pi times frequency. And we plug inside, and we get ym equals 10 over omega square becomes, and then there is a 2, so it ends up 4 pi squared. We can those to become 2 pi squared, and then we have mu lambda f cubed. Just plugging all those numbers, we will get the answer is 0.0032 meters. So we have a maximum amplitude of 2 millimeter.